In section 2.1, we're solving literal equations. We're asked to use our properties of solving equations to solve for specific variables. So in number 1, they give us a formula and they tell us to solve for r to get r by itself. The first thing we're going to do is subtract p from both sides. So we have a minus p equals prt. Well, if we're trying to get r by itself, we want to divide both sides by p and t. Whatever you do to one side, do to the other, because then that goes away and that goes away, and it leaves us with just r. So we rewrite a minus p over pt is equal to r, and that's all they ask us to do, is to solve for r. In number 2, they ask us to solve for base 2. So first of all, I'm going to rewrite this. A equals 1/2 h b1 plus b2, and I want to get b2 by itself. So the first thing, I want to get rid of the fraction. I multiply everything by a 2. This whole thing is one term, so I just multiply that whole term by 2. 2 times a is 2a. This 2 cancels this 2, so I just have 1h times b1 plus b2. Now I'm going to distribute here. So that's 1 times h is just h times b1. 1h times b2 is just h b2. And I bring down 2a. To get b2 by itself, first of all, I need to move this term to the other side. Move it over. So I'm going to say that's 2a minus h b1 equals h b2. Well, to get b2 by itself, that means I need to divide everything by h. Whatever you do to one side, do to the other. Then I have overall 2a minus h b1 all divided by h is equal to our b2. And that's all they ask us to do. They ask us to specifically solve for base 2. In problem number 3, they ask us to solve for p, and I see that I have 2p. So the first thing I want to do is group that. So I have q, and I'm going to factor out a p. So if I take p out of this, that just leaves me a 1 minus, and if I take p out of that term, it just leaves me with n. So I factor out a p. Now to get p by itself, I need to divide both sides by 1 minus n, which is in parentheses. Whatever you do to one side, you do to the other, because now those parentheses cancel, and you just have q over 1 minus n is equal to p. We're going to go into section the first part of video 2.3 at this point. In section 2.3 in part 1, we're going to talk about quadratic equations, which is represented by this format, where a cannot equal 0. The first thing they're going to ask us to do is to solve by factoring. I'm going to do rooftop method, which says there's a known coefficient of a 1 there. You want to know what multiplies to give you 1 times negative 10, what factors, but adds to give you a negative 3. So to start, I'm just going to do factors of 10. That's 10 times 1, 2 times 5. Now, I need it to be a negative 10, so 1 has to be positive and 1 negative. But my idea is that I need it to add to give me a negative 3. Well, then I know if I put a negative right there, then that's going to give me 2 times negative 5 is negative 10, which is what I need. And if I add negative 5 to 2, I get a negative 3, so that's what I need. So I stop and say, these are my factors. I take whatever this coefficient is, a 1x, and I write it 2 times. And then I put it, like fractions, I put it 1 time over this factor, 2. And the next time I put it over this other factor, negative 5. And then I rewrite them in parenthesis form. So I read it as x, and since that's a positive 2, I have x plus 2. And this one is going to be x minus 5 because it's a negative. And I set it equal to 0 just like it is up here. Drop that down. Now I take this first term, x plus 2, set it equal to 0 and solve. And then I take this second one, x minus 5, set it equal to 0 and solve. And we get x by itself, and we get x equals negative 2 and x equals positive 5. That's our solutions. X equals negative 2, x equals positive 5. In problem number 2, we're also going to factor using rooftops. So I want to know what multiplies to give us 8 times negative 5, which is negative 40. But when I add them, the two numbers, the factors, I want to get negative 18. So I start off by factors of 40. 1 times 40 is 40. 2 times 20 is 40. 4 times 10 is 40, 8 times 5 is 40, but I want to use the two that one has to be positive and one has to be negative for it to multiply to be negative. But I want to use the two that gives me a negative 18. The only ones that could give me 18 are these two numbers, and then I say, oh, 20 needs to be negative. These are my factors, and that's the one I'm going to use. So I come back over here, I take whatever this coefficient is, and I write it 2 times. 8x, 8x. I put it one time over the first factor, which is a 2. I put it one time over the second factor, which is negative 20. And then separate, I simplify these fractions. So I'm going to simplify that. Divide by 2 and you get a 1. Divide by 2 and you get a 4. So I'm left with 4x, and that's positive 1. So 4x, and that's a plus 1. Over here, I divide by 4 and I get negative 5. Divide by 4 and I get 2. So I have left over is 2x, and then I have minus 5. Bring down equals 0. So now we're ready to set this one equal to 0 to solve, and then we're ready to set this one equal to 0 and solve. So subtract 1, divide by 4. So this one is x equals negative 1, 4 is the solution, one of the solutions. And I come over here and I finish solving to get 2x equals 5, divide by 2, and x equals 5 halves. So my solutions are negative 1/4 and positive 5 halves. Next we look at square root principle. The formula just says to undo a square you take the square root of both sides. X equals plus or minus, and then the square root of 4 is 2. So our two solutions are positive 2 and negative 2. On problem number 2, before I can solve, I need to divide both sides by 3, and I get x squared is equal to 11. To undo a square, you take the square root of both sides. When you take the square root of both sides, you get plus or minus. X equals plus or minus the square root of 11, and that doesn't simplify any further. Number 3, I need to move 18 to the other side, and then I have 9x squared equals negative 18. Divide both sides by 9, and I get x squared equals negative 2. Take the square root of both sides to undo a square root, and you get x equals plus or minus, and that is written as negative 1 times the square root of 2. This component is I, so that becomes I square root of 2. X equals plus or minus, and that's recalling that we know I is equal to the square root of negative 1. That is a known fact, so we made that substitution in that place right there. This last problem we're asked to find x-intercepts and zeros. They give us a function, the graph. The x-intercept is where it crosses the x-axis, negative 2, 0, 3, 0, and the zeros are just the x values of the intercepts, negative 2 and 3. Over here, x-intercept is 3, 0. The 0 is just the x value.